LLMs are great, but they have some significant limitations. They can search the web, but they don't have access to real-time data. Or you can't connect them to your database to make CRUD operations. And you cannot store data to reuse it across different AI tools. Most LLMs only come with a few built-in tools, like official email and calendar connectors. This is exactly why MCP servers are becoming so popular. They let you create your own connectors where you can fetch real-time data, connect to databases, integrate APIs, or even use other AI tools. And you can use your server across any LLM and AI tool that supports MCP. So today, you are gonna learn everything you need to know about MCP servers. We'll start with the basics and explore how to use tools, resources, and prompts. Then we'll build something real, not just a simple calculator or weather API demo. We'll create a fully functional project planner MCP and we'll deploy it for free. You can use it remotely from everywhere and share it with others without exposing your source code. Here is what we are gonna build. Users will be able to log in and create projects. For each project, they can add features or to-do tasks with priority and status. All data will be stored in cloud storage, so even if you close your LLM or switch to another AI tool, your data will always be there waiting for you. You'll be able to create, delete, and update projects and tasks, fetch specific items, and filter tasks by status. And since we'll deploy the server, you'll be able to use your MCP on any device without setting up anything locally. We'll also add authorization, so you can control who can access your tools and data. So if you are ready, let's dive in, learn the basics, and start building our project. To understand MCP, we first need to understand the problems of AI models. AI models are trained on data up to a certain date. They don't actually know anything beyond what they were trained on. They can't access your database, read your company files, or retrieve information from your systems. Everything has to be copy-pasted into the conversation. Of course, there are some built-in tools that you can connect to your email account or note-taking application or read data from a file, but nothing more. To solve this problem, you can use an automation tool like n8n. You can make an API request, fetch and send data, connect to other services or AI tools. But in those systems, you have to define the flow. AI doesn't decide anything. It just follows your instructions. If conditions change, the flow doesn't adapt. But with an MCP server, instead of you deciding the flow, the AI decides what it needs. You just create tools and leave everything else to AI. Based on the user's prompt, it will figure out what tools need to run. MCP stands for Model Context Protocol. This protocol provides a shared communication standard between AI models and tools. When you use a web browser, it doesn't magically know how to talk to every website. It uses a protocol called HTTP that defines how browsers and servers exchange information. An MCP is just like that. This protocol allows your MCP server to integrate with different AI tools and models. This is why people define MCP as the USB-C for AI. MCP provides a universal standard for AI integration. Define your tools and use them everywhere. When you create an MCP server, there are three main components: resources, tools, and prompts. Resources allow servers to share data, like files, database schemas, or documentation. So when you ask AI for an information, it can bring it using a resource. Tools enable models to interact with external systems, such as calling APIs, querying databases, or running functions. And prompts allow you to create reusable templates for complex instructions. So instead of typing out the same long prompt every time, you can just call the template. With this information, you are ready to create your first MCP server. We'll start with a simple example to understand how these components work. Then we'll create a real project. Okay, I created a new folder, and inside this folder, we'll create our MCP server. Let's open the documentation, modelcontextprotocol.io, and on the left menu, I'm gonna choose Build an MCP server. I'm gonna scroll down. And as you realize, we can use different languages. But for this tutorial, we'll be using Node.js. And one thing you should keep in mind before starting, when you create a local MCP server, you are actually creating a standard input-output based server, not a regular HTTP based server. That means our server will receive and send messages using standard input-output. So if you write a standard output like console log, it's gonna intercept the communication and break your server. So if you want to log something, use console.error instead of console log. And later, we'll create an HTTP-based server and deploy it to the cloud. Okay. I assume that you already have the Node.js and npm. If you don't have, just download them. And here, firstly, we are going to initialize our application, and we are going to need these dependencies. Let's install them. I'll open my console. npm install Model Context Protocol SDK and Auth. And for the dev dependency, we are going to need the TypeScript. Let's install them quickly, and after, inside the source folder, we are going to create a file called index.ts. We are going to write everything inside this file. Okay, there is a warning because we didn't initialize our application. I'll say npm init. Okay, our package.json is here. Right now, we can install our dependencies and the dev dependencies. Let's create our index file, source folder, index.ts. Let me close this terminal. And since we want to use import-export, I'm going to open my package.json, and the type will be module. And inside the scripts, we are going to have the build script. We'll be using TypeScript, so I will say tsc. Basically, it's going to build our TypeScript application inside the build folder. So we are going to be using the file inside this folder. Of course, to run TypeScript, we'll need the TypeScript configuration. So I'm going to create tsconfig, and it will be a regular configuration. You can find this in the documentation here. And finally, we can create our server. We need to import MCP server and standard IO server transport from MCP SDK. And to validate inputs, we are going to be using Auth. So let's copy here, open our index file and paste. And now we are ready to create our server. I'll say const server, new MCP server. And inside, we are going to give the name, let's say my first MCP. We can give any version, let's say version 1. And we are going to add the capabilities. Remember, we have 3 main primitives. For now, let's just use tools. And after learning how to use it, we are going to add the others. So let's create our first tool. I'll create a really basic one that will take 2 numbers and return the total number. But don't worry, we'll create a real-world example. You are just learning how it works. So I will say server.tool, and inside I'm going to give the name, let's say add numbers, We can give any description, add 2 numbers, and we are going to pass the param schema, which is the type of the inputs. You can directly define a type or interface here, but we have to validate the inputs. The easiest way to do this is using Auth. So let's define the type of the first number. I will say Auth is going to be a number, and we can give any description. It's going to be the first number. Let's do the same thing for the second one. And now we can create our function, take the params, and return what we want to return. So I will say, take the inputs A and B, and return content. It's going to be an array, and the type will be a text. And the text we want to return is A plus B. Let's actually say total is A plus B. And that's all. This is why we are using MCP. It has a standard structure and output, so we get the same result no matter which AI tool we use. Now we can connect to our server and run this tool wherever we want. To do that, I'm going to create a main function. I'm going to create a transport layer, and it will be standard I/O server transport that we have imported here. It basically allows our server to communicate with the AI tools. Let's connect to the server using this transport. And if there is an error, we'll log that error, but remember, instead of console log, we need to use console error. And we are going to exit the server. Okay, right now we can test our tool. Let's open our terminal and build our application. I'll say npm run build. And as you can see, it created this build folder, and inside we have the index.js. But before adding this server to any AI tool, let's test it to check if it works as we expect. So I'm going to open a new terminal and write npx model context protocol inspector. And it's going to open our inspector on this port number. The comment will be node. And here is going to be the build folder and the index file. Let's connect. And here we can see all our resources, prompts, and tools. Let me zoom out a little bit. Okay. And if I list the tools, we can see our first tool here. Here is the description and inputs. If I give any number and run the tool, this is the response that we expected. So right now we can add our MCP server to Cursor, for example. I'm going to open the Cursor settings, Tools and MCP, and add custom MCP. Inside this object, we can add all our MCP servers. So let's add our server. I'm going to give it a name, my first MCP. And again, as we did for the inspector, we are going to add the comment and arguments. So let's say comment is going to be node args. And we are going to add the exact path of our index file. Just like that. I'm going to save. And as you can see, it's enabled and it includes our tool here. Okay, right now I'm going to open my chat, AI chat, and let's write add 5 and 6. And as you can see, it runs our function. When you run this tool for the first time, it's going to ask your permission. And when you allow, you are going to see the result. Okay, awesome. We can also test it on the Cloud application. Let's open the settings, developer, and edit config. When you click here, it will open the folder that includes the Cloud Desktop config. Let's open this using our code editor. And again, I'm gonna add my server and save. But after adding a new MCP server or adding new tools to your MCP, you should restart your application. So I'm gonna restart. And let's see right now. Okay, it's running. Let's try. As you can see, I'm using my tool for the first time, so it's asking my permission. Let's allow. And it returns our response. Using this response, Cloud answers our question. Okay, right now, let's add something more useful. I'm gonna create a new tool. And I want to fetch a user's GitHub repositories based on their username. When you ask an LLM to do that without using MCP, it will probably search the web for the GitHub profile, and it may not get all the repositories. So what we want instead is to create a tool that will directly make a request to the GitHub API, fetch all the user repositories, and return the data in a consistent way. So let's give a name. I'll say get GitHub repos. And the description. We are going to have a single input, and it's going to be a username. It will be a string. Let's say GitHub username. Our input will be username. And using this string, we are going to make a fetch request. In this case, here is going to be an async function. And let's say const response, await a fetch request, and the endpoint will be api.github.com. And the endpoint will be users. We are going to pass here our username. And we are going to find all the repositories of this user. And to make this request, we are going to give a headers, user agent, and let's say MCP server. We are giving these headers because we don't have any API key, so GitHub can reject our request. To prevent this, we are adding this header. Okay, I'll say if the response is not okay, we are going to throw an error. Let's say GitHub API error. And if everything is okay, we can get the response JSON. And since it's going to include all our repositories, we can create a list. Get all the repos. Of course, here is going to be semicolon. I'm going to be using map. And for each repo inside, let's also get the index number. I'm going to return index number +1 and repo.name. Basically, for the first repo, it's going to be 1, the repo name, 2, the second repo, and the others. And we can join them using a space. I'm doing this because if we don't give any space, it's going to write all the repositories in just one line. And let's change this text. GitHub repositories for the user. Let's say for this username. And we are going to pass here the total number of the repos. And again, I'm going to give a space here and my repo list. Let's try. I'm going to build my application again. Our inspector is working. Let's refresh the page and connect. And as you can see, Our tool is here. Let's give a name and run our tool. As you can see, there is an error. This is why we are testing this before using it in AI tools. Let's see. Okay, it should be users. Okay, let's do the same thing again. I'm gonna refresh, connect, list my tools, and try again. And as you can see, the response is here. Okay, it works. If you want to, you can test it on Cursor, or if you are using VS Code Copilot, you can add your server there also. Or if you want to, let's test it on Claude. Again, I'm gonna restart. And let's ask for the same thing. Let's be kind. I will add please. I'm gonna enter. It tries to run our tool. I'm gonna allow. And they are here. After the response, it adds some comments here. And right now, let's close our tools. And let's see how to create an MCP resource. Remember, resources are meant for reading information, like files or documentation. At this point, you might ask, why would I need this if I can just upload my document to the LLM directly and get the information? And you are right, that works for the static files, but if your document changes frequently, you have to download and re-upload it every time. And the same goes for documentation. Whenever it's updated, you have to repeat the same process for each version. But with an MCP resource, you can automatically fetch or update the documentation on the server, and this way, every time you use your AI tool, it always accesses to the latest version of the resource. I created a simple doc file. Let me create here a data folder, and I'm gonna paste my document inside. It includes some apartment rules. Of course, it can be a long PDF or pages of documentation, but let's keep it simple for the test purpose. So I'm gonna create my resource, server.resource. Again, I'm gonna give the name, let's say apartment rules. And as you can see, we should pass here a URI, and let's say rules and all. This URI is basically a unique identifier for this resource. So when your AI assistant wants to access your resource, it requests them using this URI. And after that, again, we can give a description. And also we need to add the type of the file, and it's gonna be text plain. Basically, when you read any document, PDF or text file, it's gonna be text plain. If you are using any JSON file, it's gonna be application JSON. And finally, we can create our function. I will say async. We are gonna get the URI and return our content. But before, we need to read our file. So I will say const rules await. To read our file, we are gonna need a library called fs. And to find our file, we also need path. So I'll say fs.readFile. Let's import them, by the way. Fs and path. And we are going to pass here file location. To do that, I'll say file name, file URL to path, and pass here import.meta.url. We also need to get the directory name. And we are going to be using path. And we are going to pass the file name here. And inside, we'll be using path.resolve, the folder name, and the location of our file, source data rules.doc. It can be a little bit complicated, but don't worry about here. It doesn't have to be a local file. You can fetch it anywhere else. By the way, its type will be UTF-8. And let's return our response. I'll say return contents. It's going to be an array. We'll pass this object, and it's going to include our URI, but this URI is not a string. Let's transform this first. URI string URI.toString. Okay, we can use it here. Again, we are going to add the type, and finally our text, and it's going to be rules. I'm going to save, and let's test it. I'm going to build. Oops, it's going to be npm run build. I'm going to refresh my inspector, connect, and here we have the apartment rules. Okay. Right now we can use it in our LLM. I'm going to restart quickly. And if I click here, you can see our MCP server, and we can choose our resource, apartment rules. So if you ask any question, it's going to answer according to our rules. And it's here. And finally, let's see how to use MCP prompts. They are not as commonly used as tools or resources, but they can be really useful when you need to use a long prompt repeatedly in your LLM. Instead of typing out the same detailed instruction each time, you can give that prompt a unique name in the MCP server, and whenever you call that name, it will automatically generate the full version. For example, let's say you want your AI tool to explain the given SQL code. If you just write explain this and paste your code, you might get a short response. So each time you have to write something like this. Give me a detailed explanation of the following SQL query in plain English, make it very detailed and specific for a beginner to understand. So instead of writing this long prompt every time, let's make this easier using MCP. So let's create a prompt. I'm going to give a name, explain SQL, and description. We'll get the SQL code as an input. So it's going to be a string. Describe the SQL query to explain. And I'm going to create my function. We'll get the input, and we are going to return messages. It's going to be an array, and in our message, we should pass here the role. It's going to be a user prompt, and inside the content, as we always do, we'll give the type. It's going to be a text, and the text will be our prompt. So let's paste our prompt. I will close this menu. And let's paste our SQL code somewhere here. Okay, right now we can build our application, npm run build. Let's open our cursor settings, disable our MCP server, and enable again. And as you can see, we have the prompt, explain SQL. So let's open our LLM chat. And I'm going to be using /. And as you can see, it shows our ready to use prompt. I'm going to choose it. It asks our input, which is the SQL code. I'm going to paste my code and enter. Let's send our message. And the answer is here. Okay. So this is how you can use prompts. If you have a long detailed prompt, you can define it inside a short prompt name and call it whenever you want. It can be really useful, especially if you are creating an image. Okay. So we finished our basic project. You know how to create an MCP server, how to create a tool, resource, and prompt. So now we can create something bigger, a project planner MCP. But for this project, we'll use a remote MCP instead of using a local one. That means we can deploy our server online, get the MCP server URL, and use it anywhere we want. Because when you create a local server, only you can use it. The only way to share it with other people is to create a GitHub repository or create an npm package. So users can go to your repository, download the code, and run it on their machines. But it's not ideal because every time you make a change, they would have to download and run it again. Also, if you want to use it on another device, you would have to repeat the same process, download the code, and run a new local server. Another downside is that a local server only works while it's running. That means you need to keep it running or keep serving the output file. But with a remote server, you can basically add the URL for each AI tool, and whenever you update your server, it will keep using the latest tools and resources, and it can be used by other people and multiple devices. The easiest way to do this is using CloudFlare. It's one of the first platforms that lets you create and deploy MCP servers without any configuration. It even includes built-in authentication, so you can easily share your MCP server with other people. The Model Context Protocol uses standardized authorization flows to connect clients and servers. Normally, this requires complex configuration, managing credentials, tokens, and authentication logic, but with Cloudflare MCP, everything is built in. You just create your provider's client ID and secret key, and Cloudflare handles the rest. When you create a remote MCP server, there are two transport options, SSE and HTTP. SSE uses two endpoints, one for requests, one for responses. Most MCP clients currently use this method. Streamable HTTP is simpler, using just one endpoint for two-way communication. SSE will soon be deprecated, and streamable HTTP will become the standard transport, and the Cloudflare Agents SDK supports both. So you can start with SSE today and switch to streamable HTTP later without changing any configuration. You can create stateless MCP servers using MCP TypeScript SDK, but this Agents SDK allows your MCP server to remember previous tool calls and cache API responses. It also includes WebSocket hibernation, which means your agents only consume compute resources when actively processing requests, and it dramatically reduces your cost. Basically, Cloudflare is currently the best option for building remote MCP servers. And the best part is creating and deploying your servers is completely free. If you want to use other platform services like database, memory storage, or file storage, Cloudflare offers a very generous free tier, so you won't have to pay anything to get your project started. Let's go ahead and create a real MCP project. So I will show you how easy it is to build and deploy MCP servers with Cloudflare. So I'm gonna create a new project, and let's open the documentation. This is a great documentation. You can use this page, but they also prepared a great page where you can learn MCP step by step. So let's get started. We already know the basics. I'm gonna skip here. So we'll create a new Cloudflare project using its MCP template. It doesn't have the authentication, but don't worry, after learning the basics, we are gonna add it. Okay, before running this code, let's also open our dashboard. Since we want to deploy our application, we need to visit the workers page. I'm gonna zoom in, by the way. And when you visit this page, it's gonna automatically create your workers environment. Okay, so I can close here, copy my code, and let's turn back to our editor. I'm gonna open my terminal, paste my code, and it's gonna install everything inside this folder, but we don't need to do that. I want to install everything inside my root folder, so I'm gonna add here dot and enter. We don't need to use Git. And as you can see, you can directly deploy your application. If I choose yes, it's gonna log into my account. If you didn't log in before, it's gonna open the browser and you can log in. And after that, it's gonna deploy your application. And this is gonna be the URL we are gonna be using to reach our MCP server. If you are deploying your application for the first time, it's gonna take a while because it's also creating a domain and waiting for the DNS changes. And it's ready. So we can reach our server using this address. But before, let's see what's inside our index file. I'm gonna close this terminal. And as you can see, it uses classes, but don't worry, we won't be creating any classes or anything like that. The only difference is, instead of writing server tool, we just add here this.server.tool, and the others are the same. The name, inputs, and the function. So I'm gonna close this menu, and let's get rid of these tools. There are some simple examples like add tool and calculate tool, but we don't need them. I'm just gonna remove and change the name of my MCP server. I'll say project planner. Right now we can write our first tool, but before, let's define our types. In our server, we'll be able to add projects and to-do lists. So at the very beginning, I'm gonna create an interface and I will say project. Each project will include an ID. It's gonna be a string. We'll give a project name, project description, and we'll have the created at and updated at times. Let's create one more, and it's gonna be to-do. Again, we'll have the ID, and each to-do will belong to a project. So I'm gonna add here project ID. Let's say title description, created and updated at dates, but also I'm gonna add here a status, and we'll have three options. It can be pending, or in progress, or completed. We'll also have the priority, and it can be low, medium, or high. So right now we can write our first tool. Inside the init function, I'll say this server and tool. And as we always do, we are gonna give a name. I'll say create project. We can give a description. I'll define my inputs. We'll give a name and we are gonna validate our input. Remember, it's gonna be a string. And we can give any description. It's gonna be the project name. And one more, we can also give a description, but it will be optional. So we can create a project with only a name. Let's change here. And now I'll write my function. It's gonna be an async function. We'll get the inputs, name and description. For each project, we need to have an ID. So let's create a random ID. We are going to be using crypto and random UUID. So let's create our project. Its type will be project type. We are going to pass here our project ID. We'll give the name and the description. But remember, it's optional. So I'll say description, but if it doesn't exist, leave it empty. And the created at time will be new date. but we should transform this JavaScript date into a string. And I will do the same thing for the updated add time. Okay, so right now we can return our response. I'll say return content. Remember, it's an array and it includes our type. Response type is going to be a text. And the text will be our project, but it's an object. We should return a text. So I'm going to be using stringify and pass my project here. But since it's a string, it's going to write everything in just one line. To prevent this, I'll also give here a space parameter. Let's say 2. Basically, for each line, it's going to give a space. Okay. Right now, our first tool is ready, but we should actually store this project somewhere. So when the user closes the AI tool, everything will be still available the next time. And we'll also be able to fetch the same data across different AI tools. To do that, we can use a database. Let's actually open the previous page again. Storage and databases. And as you can see, we can use an SQL database. But for this project, I prefer using its key value storage because it's much faster when it comes to reading data. It's almost instant. And CloudFlare's free tier gives 100,000 read operations and 1,000 writing operations daily for free. This is incredible. The free tier actually gives you almost everything, like database usage, file storage, and even some AI tools. But also, I want to let you know that if you are a student, you can go far beyond the regular limits for 1 year. You'll get everything in the free tier, plus millions of requests and logs, more CPU and build time, and increased KV storage. It's an amazing opportunity for students. If you are interested, I will leave the link in the description so you can click and get more information. Okay, in our server, we'll basically store our projects like project and the project ID, and the value will be all this information here. It's going to be an object and it will include all the fields here. And when we create other project, it will be project and some other ID, and the value will be whatever inside that project. So when we search for any project, we'll be using these IDs. Okay, so let's create our KV storage. To do that, we'll be using Wrangler, which is Cloudflare's command line tool. So I'll say npx Wrangler, or if you install Wrangler globally, you don't have to use npx, you can directly say Wrangler. If you want to use it like that, just open a new terminal and install it globally. But I already have. I'll say kv namespace, create, and you can give any name you want. Let's say project planner, store. I'm gonna enter. I'll say yes. So it's gonna write the configuration in the Wrangler JSON. This is gonna be the name, so I'm gonna enter. If you want to, you can directly use your cloud resource. So let's say yes. Let's open our menu. And if you check the Wrangler JSON, you can see your KV namespace. It's here. And whenever you make a change in this file, I recommend you run Wrangler types. So it's gonna add the new binding types automatically. It's here. Okay, so let's close this menu and console, and let's add our project into our store. So I will say await env.projectPlannerStore. Let's give our type here as env. And as you can see, we can get, list, and delete items, but we are going to choose put because we are creating a new item. And inside, we are going to add our key and its value. Remember, our key will be project and the project ID. And the value will be this project object. But we can store only strings. So let's use JSON stringify. and pass here our project. Right now we saved our project and sent the response, but I also want to store a list of all my projects because later, when we also add the to-do items inside the storage, it will be hard to get all the projects or all the to-dos. So let's say const project list. Actually, we can define it here before the init function because we'll be using it again and again for the other tools. So let's create a function, async function, get project list. It will be a promise, and we'll pass here a string array. So I'll say const list data, await, and again, we'll be using our storage. And I will say get, and we are going to get all the project list. And we are going to return our list. I'll say return. If list data exists, transform that into an object and return. If it doesn't exist, return an empty array. And I can do the same thing for the to-do list. Get to-do list. And we will fetch all the to-do items that belong a project. We can get a project ID here, which is a string. And using this ID, we can fetch all our to-dos. So let's say project, the project ID, and to-dos. And also, maybe instead of writing this long string again and again, let's make it simpler. We are just going to call it as KV. Its type will be KV namespace. And I'm going to return this long string. So we can directly use here this.kv. Okay, it's much cleaner. Let's do the same thing here. And here. So right now, after adding the project, we can add this project into our project list. Let's get the previous ones. Project list. Await. We are gonna call our getProjectList function. And inside this array, we are gonna add one more item. ProjectList.push. And we are gonna add our first project. Remember, inside this list, we are just storing our project IDs. And I'm gonna save this list. So I will say await kv.put project list and pass here the new list. So here we created a new project, and here we updated our list. So this was our first tool. Let's create another one. Server.tool. And this time we are going to create a new to-do. I'll give the description and inputs. Let's remember our types. We have the project ID, title, description, status, priority, and the dates. So we can get the project ID. It's going to be a string. Let's say project ID. Let's create more. Here is going to be the title. Here is going to be the description and priority. By the way, this is the init function. Our tool should be inside this function, just like that. Of course, description can be optional. And the priority. But remember, we have only 3 options. So let's transform this into an enum. And it's going to be low, medium, or high. Of course, inside an array. Let's change the descriptions quickly. So I can create my function right now. I'll say async. I'll get the inputs. And let's create our to-do. But before using this project ID, we should check if the project exists or not. Project data, await kv.get, and we are going to pass here project and project ID. And I'll say if it doesn't exist, throw a new error. And let's say project not found. Okay, right now we can create our to-do. Firstly, let's create an ID. To-do ID. Remember how we are doing this. Crypto.randomID. And let's create a to-do object that includes an ID which we created. The project ID will be, actually, let's write here our type. So we can use the auto completion. Project ID is going to be the ID that comes from the client, title, description, but remember it's optional, so I'll say description. If it doesn't exist, empty string. Status will be pending because when we create a new to-do, by default it's going to be pending. I'll say priority, and if it doesn't exist, it's going to be medium. And let's create our dates, new date, and it's going to be a string. Okay, right now we can save it. So I'm going to be using kv.put, and let's pass here to-do, and again I'm going to add the to-do ID, and its value will be this to-do object. And as always, it should be a string. And now we can update our to-do list. Remember, our function is here. We can get the previous to-do list and we can update. So let's say const to-do list, our function, and we'll pass here our project ID. After getting our list, we can push our new item, which is going to be its ID. And finally, we can update our list. Project and project ID and its to-do list. And we are going to pass here our new list. Just like that. And finally, we can send our response. Remember, we are sending a content, and inside this array, we have the type, and we have the text. And I'm going to pass my to-do. And again, I'm going to give a space. And let's see if we have any error or not. Okay. So right now we can create a project, and inside this project we can create a new to-do. So let's create a tool that we can list our projects. Actually, let's do this before this. Create to-do because it's related to project. So let's say server.tool, give the name and description quickly. We'll not need any input, so I'm gonna leave it empty because we are gonna fetch all the items. I'm gonna create my function, and let's get the project list, await, and our get project list function. And remember, it includes all our project IDs. So using those IDs, we can fetch all the projects. So I'm going to create here an empty array, projects, its type will be project array, and it's going to be an empty array. And for each ID inside this project list, we are going to fetch the data. So let's say for project ID of project list. So for each item, we are going to get the data, let's say project data, await kv.get, and we are going to pass here project and every single project ID. And if it exists, we are going to push this data inside this array. Projects.push and pass our data. But remember, it should be an object. Just like that. And finally, we can return our response. Content array, and that includes our type. And the text will be JSON stringify and our project list. And as we always do, we are going to give space between each line. And that's all. Right now we can get a single project. Let's actually copy here and paste. It's going to be get project. The description will be get a specific project by ID. We'll get the project ID as an input. It's going to be a string. And let's write a description, project ID. Let's get our input here. Let's get rid of them. And right now, using this ID, we can fetch our project. So I will say project data, await. We are going to be using our store and get function. And remember, we are storing them just like that, project and the project ID. And if it doesn't exist, we can throw an error. Throw new error. And let's say project not found. Remember, when we fetch from our store, it returns a string. So let's transform this into an object. Const project. Its type will be project. And I'm going to parse my string. Just like that. If you want to, you can fetch all the to-dos of this project. Let's do that. Actually, for this, we can create a new function here, because later we are going to need it in other tools. So let's say private async function, get to-dos by project. We are going to pass the project ID, which is going to be a string, and it's going to return a promise, which includes our to-do list. Remember, we have here the to-do list function, and this list includes the to-do IDs. So using each ID, we can fetch the actual to-do. Firstly, let's get our list. I'm going to call my function and pass here the project ID. And I'm going to create an empty array for the to-dos. And for each ID, let's fetch the to-do data. So again, I'm going to be using for const to-do ID of to-do list. And using the ID, we'll get the data. kv.get to-do and the to-do ID. We can push it into our list. To-dos array.push JSON parse and to-do data. And finally, we can return our to-do list. Just like that. Right now, we can use this function here. Get a single project. And we are going to pass here our project ID. And right now, we can send our project, single project, and all of its to-dos. Okay. Right now we can create a project, we can get the project list and a single project, and right now we can delete our project. I'm gonna copy here, create a new tool, and let's say delete project. And be careful, when we delete a project, we should also delete all its to-dos. Okay, again we will get the project ID, we'll search for this project, if it doesn't exist, we'll throw this error, and here we can delete all of its to-dos. We already fetched here our to-dos, let's get rid of here. After finding to-dos, we are gonna delete every single item. So let's say for const to-do of to-dos await this.kv and delete, and the key will be to-do and its ID. Let's say delete all to-dos. After deleting to-dos, we can finally delete our project. So again, kv delete, but this time here is gonna be project and the project ID. And also, we can delete all the to-do list of this project, project ID, and to-dos. So let's write here a command, delete project to-do lists. And here is gonna be delete project. And what else? We also have the project list. Remember, if we delete a project, we should also delete it from the list. Let's say remove project from the project list. So I will get my project list and filter that list. We are gonna remove this project and we are gonna update our list. So let's say project list. We are gonna call our getProjectList function. It's gonna return all the IDs, and we are gonna filter our list. Let's say updated list, project list dot filter. We are gonna search for ID, and that ID shouldn't be equal to our project ID. Basically, it's gonna remove this project ID and leave the others. And finally, we can update our list. I'll say put project list, and we are gonna pass our updated list. Okay, let's write here a text. We are just gonna return a text. Project and all its to-dos have been deleted. Okay, what about our to-do? We can also update our to-do. So I'm gonna duplicate here. And its name will be update to-do. Let's change the description. We'll get the to-do ID to update. We can pass title, description, priority, and also the status. Remember, it can be pending, in progress, or completed. But since we are updating our to-do, they all are going to be optional because we might just want to update the status or just the title. So let's add here optional. I'll copy this and add for the others. Oh, actually, we already have. Let's say new to-do title, new to-do description, and the others. So here is going to be to-do ID, title, description, status, and priority. And let's get rid of here. Firstly, we are going to get our to-do data. If it doesn't exist, we are going to return an error. If it exists, we are going to update its fields. So let's say to-do data, our store get function, and pass here to-do and its ID. If it doesn't exist, throw an error, to-do with ID not found. And after that, remember this is a string. Let's transform this. I'll say const to-do. I'm gonna write its type and JSON parse. And finally, we can update the fields. But remember, they all are optional. So we have to write our conditions. I'll say if title doesn't equal undefined, to-do.title will be the new title. I'll do the same thing for the others. Description, status, and priority. And finally, I'm gonna update its updated at time. To-do.updated at time, and it's gonna be a new date. Okay, right now we can update our to-do using our storage. Let's do this quickly. Put to-do and the to-do ID, and pass here our new data. Just like that. And we can pass it here. Okay, it's already here. So finally, we can delete our to-do. Let's copy here. Create a new tool. It's gonna be delete to-do. Delete to-do from a project. We are just gonna need the to-do ID. Let's delete the others. And here. So again, we are gonna get our data. If it doesn't exist, we are gonna return this error. And finally, we are gonna remove our to-do. But remember, we also have the to-do list. We should update that. So let's say remove from projects to-do list. Let's get the list first. Await. I'm gonna call my function get to-do list and pass here to-do.project ID. Let's create a new one, updated list. And again, I'm gonna filter my list, to-do list.filter. We are gonna check every single ID, and this ID shouldn't be the ID that we get from input. And let's update it. Remember, our to-do list is inside project and the project ID, to-do.project ID, and its to-dos. And we are going to pass here the updated version. Just like that. And finally, we can delete our to-do, the delete method, and pass here our key, which is to-do and its ID. Let's say remove to-do. Okay, let's get rid of here, and let's change our text. To-do has been deleted. What else we can do? I'm gonna create another tool, and we'll be able to fetch a single to-do. So let's say get to-do and get a specific to-do by ID. Again, we'll get the to-do ID. We are gonna check if it exists or not. If it is, we are gonna get our to-do and return it as a response. So I'm gonna get rid of them. We'll directly pass our to-do here. just like that. And finally, we can get all the to-dos of a project. So let's say list to-dos, list all to-dos in a project. So we'll get the project ID. But I want to add here one more item, and it's going to be status. Because we can ask fetch all the to-dos of this project, but we can also ask get all pending to-dos of this project, or get all in progress to-dos of this project. So let's say status. I'll say enum. I'm going to write my options here. Pending, in progress, and completed. We can also get all status. Let's make this an array, by the way. And I'll say it's going to be optional. We can just pass the project ID. And I will say describe filter by status. Let's get our inputs here. Project ID and the status. Firstly, we are going to check if this project exists or not. So I will say project data, and here is going to be project and project ID. If it doesn't exist, project with this ID not found. And after that, using this function, get to-dos by project, we can fetch all to-dos that belong to this project ID. So I will say to-dos await. I'm going to call my function and pass here my project ID. And remember, we can filter our to-dos by status. So I will say if status exists and it's not all, we are going to filter our to-do list. Let's make this let, so we can modify. To-dos will be to-dos.filter. We'll get all the to-dos, and we are going to check its status. To-do.status should be the status that comes from the client. And finally, we can return our to-do list. And that's all, I think. Let me zoom out for now to check if everything is alright. We can create a new project. We can list our projects. We can get a single project and delete that project. We can create a to-do. We can update. We can delete, get a single to-do, and get all the to-dos of a project. I think that's all. So I can zoom in and open my terminal, and let's deploy our application. It's really easy. Wrangler and deploy. That's all. Okay, our project is ready. Let's copy this URL and open our cursor MCP settings. I'm going to choose Tools. This was our first MCP. I'm going to add a new one. Let's create a new one. But this time we are going to make some changes here. Firstly, let's change the name. Project Planner MCP. I'm just going to pass here my link, and the endpoint will be SSE. In the updated version, here can be MCP, but for now, we are going to be using SSE. But for the command, we are not going to be using node. Instead, we'll be using MCP remote. To run this, you should install this library. So I'm going to open a new terminal, npm install global and MCP remote. I'm going to enter. And now I'm going to save my file And let's see. And as you can see, it's running. Let me close this terminal. And all our tools are here. Let's try. I'm gonna close here. Open my chat. And let's test it. Create a project. And I will say e-commerce app. And we can give some description here. That will be a project that uses React with a Hono API. I'm gonna enter. And as you can see, it tries to run our create project tool. Let's allow. And it's here. Project ID, name, description, and the created add time. Let's try to add a to-do. Add a to-do to my e-commerce project. Authentication will be implemented with JWT. I'm gonna enter. And now it runs create to-do function. And our to-do is here. And let's add one more to-do. In my e-commerce app, I plan to add an outless purchase. Add it to the list. Let's try. And it's here. As you realize, by default, it gives some description. So you don't have to give every single detail. Just write your idea, and it's gonna generate all the fields for you. And let's try to add a to-do, but priority will be higher. I should implement rate limiting to my e-commerce project as soon as possible. Again, it runs create to-do. And as you can see, it added here high priority, and it also added a description. And as you realize, we don't even have to pass here the project ID, or we don't even write the correct project name. I just said ecom, and it understood that it's the e-commerce application project and created a new to-do. Let's add one more project. I want to create a blog application. Let's add a to-do, and after we are gonna test it in the Cloud application. I'll implement comments functionality to my blog project, but it's not that important. And right now the priority is low. Let's say, show me my projects. It's gonna run list projects. I'm gonna allow. This is our first project, and this is the second one. And it also returns all the to-dos. Okay, it works. Let's do the same thing for the Cloud application. I'm gonna come here, settings, and developer settings. And I'm gonna edit the configuration. And it's gonna open our Cloud folder. Let's update this config.json. And I will do the same thing here. Let's open our MCP JSON from cursor. I'm gonna copy here and paste. I'm gonna save, and let's restart our application. Okay, let's see. Okay, it's running. Let's create a new chat, and I will say, what are my projects? It's gonna run our MCP. I'm gonna allow. And since we store all our projects inside CloudFlare, we can use different AI tools simultaneously. If I have an idea, I can write it here. And later, when I code, I can check my ideas, features, to-do lists, and I can update here. This is why we are using a remote MCP server. Let's ask something more. I'm gonna allow. When you are calling tools for the first time, you should allow them, and after, you don't have to do anything. And as you can see, all our to-dos are here. It also writes the priorities and status. Let's update this. For example, I completed adding authentication. As you realize, I'm not writing update or something, but it understands that it has to run the update function, update tool, and update the status, just like here. I'm gonna allow, and it's gonna update my to-do. As you can see, we have 2 more pending to-dos. Okay, awesome. So this is how you can easily create and deploy your MCP servers. Okay, we completed our project, but you might want to keep your server private so only you can use it. Or maybe you want to share it with other people, but make sure that they are authenticated and each project is stored and fetched for the correct user. You can even give usage limit for the users. To handle this, we need to implement authorization. That means before using the MCP server, everyone must log in and have the correct permissions. If you are using CloudFlare, it's really simple because it comes with built-in authentication. So I created a new project and let's see the documentation. Just open the authentication section and here again we'll create a CloudFlare application, but this time we'll use a different template. Let's copy here, open our terminal and paste our code. Again, I want to install everything in this folder, so I'm gonna remove this name. At the end, I'm gonna add dot and enter. I'm gonna deploy my application. And during this process, let's see our index file. And as you realize, we have here additional props like login, email, username, and access token. And we are going to get all this information from the GitHub handler. Basically, when a user installs our MCP server, first they need to make a request to this endpoint, and it's going to handle all the authentication process and verify the user. And also we have here a username list. Basically, you can add here the allowed usernames. So even if the user is authenticated, if their username is not here, they won't be able to use our tools. For this tool, there is no condition. Every logged in user can use it. Or this one. But as you can see, there's a condition here. To use this generate image tool, the username should be inside allowed names list. So this is how you can create private and public tools. All our tools will be private, so I'm gonna get rid of them. Let's change the name. I'm gonna leave here empty for now. After we are gonna add our username. And let's get rid of these. And add here all our previous tools. So I'm gonna delete this one. And as you can see, the authentication provider is here. We are using GitHub for the provider. Of course, you can use different providers like Google or whatever you want. But let's keep using GitHub because most of the MCP users are developers. Okay, let's come back. Scroll down. And right now, we need to create a new OAuth app using GitHub. Let's click here. I'm gonna create a new app. Let's give a name. The homepage will be our application URL. Let's open our terminal. Okay, it didn't deploy our application because there's a namespace in the Wrangler JSON and it's empty. Let's get rid of this. Later, we are gonna add our storage, but for now, let's deploy our application. I'll say Wrangler deploy. And let's see our URL. Okay, it's here. I'm gonna copy here and paste for the home page. And in the callback input, we are gonna pass here callback. Okay. Let's create. This is our client ID, and we are gonna create a client secret. And it's here. If you open your application, you'll see that there are some development variable examples here. And inside, we need to pass the client ID. Let's copy this. And the client secret. And our application is going to store the user token. To do that, we need to give here an encryption secret key. You can generate a random text, but for the test purpose, I will just say secret key. I'm going to save. And right now, instead of example, we can directly use our variables. But remember, this is for the development mode. If you open the documentation, as you can see, this example runs the server locally and it uses this file. But since we are deploying our application, we need to set the secret keys in the cloud. Let me scroll down. For the production, we need to set our secret keys using Wrangler. So let's do this for all our keys. I'm gonna paste my code. I'm gonna enter. And here, we need to add our value. I'm gonna enter and do the same thing for the others. Client secret. And the encryption key. And it's gonna be secret key. I'm gonna enter. And now we can create a KV storage for the authentication. Remember how we are doing this? Basically, it's gonna store the user information here. Let's copy this. And create. I'm gonna say yes. And I'm gonna be using the remote resource. And remember, we also need the project planner store. Let's remember our previous application. We created project planner store. Let's do the same thing. I'm gonna change the name. Let's say with Auth. I'm gonna enter. And now we'll use this store for the user information, and we'll use this store for the project and to-do information. Okay. And remember, whenever you change your Wrangler JSON, create the env types using Wrangler types. So it's gonna update the types here. Just like that. And let's start adding our tools. I'm gonna close this terminal and this sidebar. And now I'm gonna come here. First, I'm gonna paste my types. Let's paste them here. We have some functions here. Let's copy them. Before the init function, I'm gonna paste. Let's change this name. But now every project and to-do item should be specific to user. So we are not gonna store our projects like project and project ID. Instead, we are gonna also give here the username. Remember, we are storing our username here inside the props. We have the login field and it includes our username. So let's copy here. And I'm gonna change the name. It's gonna be project, user, and the username. So let's copy here. And do the same thing for the others. Username and to-dos, to-do ID, user and username, and let's add our tools. I'm gonna come here, grab all my tools, paste here, and I'm gonna change my key names. Again, I'm gonna copy here, and I'm gonna change them quickly. And that's all, I think. You can add this username anywhere you want, but make sure that you are consistent. If you add it here, for the other tools, you should also add it here. If you add at the end, you should add at the end for the others. Okay. I hope everything is alright. I'm not gonna add my username for now. I'm gonna save, and let's deploy our application. Okay, let's copy the link and add it to your AI tool. I'm gonna open my MCP JSON. You can find it in the cursor settings. And let's add one more. Give here a comma, change the project name, and change the application URL. I'm gonna paste and save. And as soon as I do that, it's gonna open this authentication page. I'm gonna approve and log in with my GitHub account. It's gonna read our user information and send it to our server. And as you can see, even if we are logged in, it returns an error because we are not authorized. Our username is not here. So this is how you can protect your servers. So if I add here my username and deploy my application again, and let's enable our server again. I'm gonna disable and enable again. And it's gonna open the authentication page. And since we are already logged in, it's gonna send this successful message. We can close the window. And as you can see, all these tools are here. If you add here any public tool before this condition, the authentication still will be successful, but the user will be able to see only one tool here, the only public tool. Okay, awesome. Right now, you can delete the previous MCP because they have exactly the same tools. To prevent any conflict, just leave this latest one. And if you open your chat and ask for your projects or to-do lists, it's gonna send an empty array. Right now, each project is specific for a user. As you can see, we don't have any project. Create a new project. And it works as we expected. It suggests some to-do items. Let's add this one. And it's going to automatically create our to-do item. Okay, awesome. You can also test it on your cloud application. And that's all. It's that easy to create MCP servers using CloudFlare. If you want to, you can create different functionality that will automatically add the user items here, or you can store them inside a database or CloudFlare KV storage. You can add different tools, resources, prompts, or whatever you want. Now you are ready to create your own project. Okay, that's all for today. I hope you liked it. If you learned something new today, please like the video. You can support the channel by using the link in the description or by joining the channel. Don't forget to follow Lama Dev social media accounts. I hope I'll see you in the next tutorial. Goodbye.